Hello, viewers. We are here to break some preconceived notions about going viral on YouTube. We've all heard the big shots say make your thumbnails neon green, keep the video over 10 minutes, and pray. As data science students, we are here to stop praying and start programming. We took 7 million trending records from Kaggle, cleaned out the noise, and ran a full statistical pipeline. But before we could predict anything, we had to redefine the word viral. If a massive creator with 100 million subscribers gets 1 million views, is that really viral?
Scientifically, no. That's actually an underperformance. So we defined virality as the view multiplier, total views divided by subscriber count. This creates a level playing field and lets us spot the nuclear explosions, which are tiny channels suddenly pulling in huge views. Videos in the top 10% of this multiplier are labeled viral. As our plots show, log virality follows a log normal distribution. The hits aren't outliers, they are the predictable tail of a mathematical curve.
To ensure our data was clean, we set a 100k subscriber baseline to prevent tiny channels from creating fake math outliers. We also only looked at videos over 30 days old. Why? Our gamma distribution proves that videos don't just explode on day 1. They have a slow burn incubation period up till about 3 weeks in. We also checked if the upload day matters. Everyone thinks you must upload in a Saturday to get a viral video, but our data shows it doesn't matter. So we dropped it from our predictor.
Next, we looked at the actual content. How to and style dominates the median views. It offers the most reliable outreach because value driven content has a higher floor than trend driven content. But there's a catch. It is the slowest to trend, taking over 10 days. Contrast that with gaming, which is just a firecracker and trends in just 50 hours. However, looking at the probability box plot, gaming actually has the lowest chance of going viral at just 2% due to severe oversaturation. Meanwhile, How to and Style has a staggering 42% chance. The algorithm heavily rewards utility over hype.
We then ran a Spearman correlation, and the biggest shock was that subscribers have a negative correlation with virality. Having a massive sub count actually makes it harder to get a high multiplier. Duration is also a major negative. As videos get longer, virality drops. The 10-minute rule for ad revenue is statistically killing your reach. Concise is the new viral.
Using these exact patterns, we built a logistic regression model to predict virality before a video is even uploaded. The heaviest negative coefficient in our model was duration at minus 2.45. To make this tool useful, we optimized our probability threshold to 0.75. For YouTube, pushing garbage to hundreds of millions of users is a disaster for viewer retention. So we use a strict filter. We prioritize precision. Our confusion matrix shows we successfully filtered out 91% of non-viral noise and still caught nearly half the actual hits, keeping false positive under 9%.
Finally, we analyzed 26,000 thumbnails using the Python package OpenCV to measure saturation and brightness. The density plots burst another massive myth. Oversaturating your image doesn't correlate with virality. In fact, for science and education, high saturation has a negative correlation. Viewers have clickbait fatigue and prefer visual honesty over neon noise.
So, what's the bottom line? Virality is in luck. The best bet is short DIY content with cleaner, natural looking thumbnails that don't affect your eyes. Our model proves that creators have a rough checklist they can follow if they want to grow their channel. Being a small channel is actually your biggest statistical advantage for a breakout hit.
Our current model doesn't account for the content quality and what's in the video. We can include the channels less than 100 K subscribers, and a semantic analysis of the title can be done to find out which emotions lead to virality. Our dataset does not separate the shorts and long form videos, so a separate analysis could not be done. A big thank you to our instructor, Dr. Shabnam Iyyani, for providing us this opportunity to explore this project. Stop worrying about the algorithm, focus on being concise, and let the data do the rest. Thank you.